Hello ladies and gentlemen, and thank you for listening to Mr. Laxton's video on these Algebra II 2.6 notes. Alright, so today we're looking at linear inequalities in two variables, and then we're going to graph these. Alright, so we've talked about graphing on a number line that looks, hey, just like this. We put, remember, like 6, and it was like open dot above 6, and then pointed to the right or the left. That's what we've talked about so far, but now we're going to graph them in two variables. Okay, so that's my essential question today is how do I graph linear inequalities? So now, first of all, we have to kind of look at a solution to an inequality. All right, so here's a solution is an ordered pair that makes the inequality true. So now it's just might not be just equal to, it can actually be greater than or less than. So is 8 greater than 10? Obviously no, so that's not a solution. Is -6 less than 4? All right, yes, -6 is less than 4, so yes, that would be a solution. So not just equal to here, we're actually just going to go through and plug these guys in again. So now like I have an x and a y, an x and a y, an x and a y, just plug these guys in to see if they're true. So here I have 2 times 1 plus 5 times 2. Is that greater than or equal to 10? So now I have 2 plus 10 is greater than or equal to 10. Is 12 greater than or equal to 10? Yes, absolutely. So this is a yes, this is a solution. All right, so now as I keep on going here, if I plug in 2 comma 1, 2 times 2 plus 5 times 1. Is that greater than or equal to 10? So now 2 times 2 is going to be 4. Plus 5, is that greater than or equal to 10? Is 9 greater than or equal to 10? Obviously, no, 9 is less than 10. So that one is no. Moving on to the last one here quickly, I don't want to spend a whole lot of time here, is 2 times 0 plus 2 times 2. Is that greater than or equal to 10? All right. Oh, excuse me, this is a 5. 5 times 2 there. So this is going to be 0 plus 10 greater than or equal to 10. Is 10 greater than or equal to 10? And no, 10 is not greater than 10, but 10 is greater than or equal to 10, so this is yes. All right, good there. All right, so we're going to use that to kind of help us here. We're going to use that to help us shade and do some different things on these lines. So here it is. Graphing linear inequalities is just like graphing an equation in slope-intercept form. There's only two differences. Now we're going to look at, hey, is this line going to be dashed or solid? A dashed is a greater than or less than. Or excuse me, less than and greater than is the way it looks there. Notice here that's kind of like an open dot. All right, so the open dot is a lot like a dashed line. So it doesn't actually include that line, it's just everything to the one side of that line. All right, and the solid is less than or equal to. Notice how that has an equal to, and then this guy has an equal to, greater than or equal to. That's kind of like a closed dot. All right, so don't forget, and I even forget this myself sometimes, even if I've done this for a long time, is that don't forget you can't just draw a straight line through that. Once you get your y-intercept and your slope, you can't just draw a straight line with it. You got to make sure, hey, is that a dashed line or is that a solid line? I even forget this sometimes as well. All right, so now here we're going to shade one side of the line. Here's an easy way to do it is we're going to test a point on either side of that graph. So if that point is a solution, everything on that side of the line is going to be a solution. If it's not a solution, everything is not a solution on that side of the line. So we're going to determine, hey, is this point that I selected, is that a solution? If yes, then I'm going to shade everything over there. If no, I'm going to shade everything on the other side. And we'll look at that in an example here in a second. All right, so this first one's kind of easy, nice for us because, hey, it's in slope-intercept form. It's in y equals mx plus b, except for it's not equal to here. This is an inequality. So I know that my m is 2, and I know that my b is -3. And we've got really good at graphing these. We go down at -3 on my y-intercept, and I walk a slope of 2 over 1. So I go up 2 over 1, up 2 over 1, up 2 over 1. Then I have to ask myself, before you go through and actually put that line in there, is it dashed or solid? This particular one is dashed because there's no equal sign. All right, so there's no equal, so this is a dashed line through here, so I'm going to put my dashed line. Nice sound effects there. All right, and now I have to shade on one side of this line. We're either going to shade above it or we're going to shade below it. And here's the point that we most like to test. We like to test 0, 0. All right, we like to test the origin because that's just the easiest one to test. But there is sometimes when you can't test that. Right now, 0, 0 is not on my line. So you've got to make sure that your line does not go through 0, 0. You can't test a point that's on the line. You have to test a point that's one side of that line. So here we go, 0, 0 is okay to use. So now let's just plug these guys in. I get 0 is less than 2 times 0 minus 3. Is 0 less than, this goes away because that's all 0, negative 3. Is 0 less than negative 3? No, that's not true. So no. So 0, 0 is not a solution, so that means everything on this side is not a solution, and that means everything on this side is a solution. So that's why we shade over on that side. We tested 0, 0. It did not work. It gave us a false statement, gave us a no. So that's why we shaded on the other side. All right, so that's going to be key here as we go on. All right, the next one is a little bit more tough because it's not in y equals mx plus b, so you got to get it into y equals mx plus b. So this guy, hey, I'm going to subtract the 2x over, I'm going to subtract the 2x. So now I have 5y greater than or equal to negative 2x plus 10. All right, now I get to divide by 5 to all these parts, divide by 5. So now I have y is greater than or equal to negative 2/5 x plus 2. And don't forget those rules that we talked about with inequalities. If you divide by a negative, you have to make sure you flip the sign. So don't forget that. All right, make sure that if that happens, that you do flip that sign. But now, hey, this guy, it didn't happen to us that time. So now this guy, hey, I can go through and graph this guy. It's got a y-intercept of 2. It's got a slope of negative 5 or negative 2/5, excuse me. Wow, I can't talk. Down 2, 1, 2, and walk over 5. 1, 2, 3, 4, 5. All right, so there are my 2 points to make my line. I have to ask myself, is it dashed or solid? This one has an equal to, so it is solid. So I have a solid line that goes through these guys. There's my solid line. And now I have to say, hey, where do I shade? So don't forget that. A lot of times you go through and graph these lines and you're like, sweet, I'm done. I graphed my y-intercept, I graphed my slope, I'm done. Don't forget that you have to either dash or solid, and then don't forget you have to pick a test point to toss some shade. All right, so toss some shade on this guy. I'm going to pick 0, 0 again. You don't have to pick 0, 0. I just think that's the easiest one. You could pick negative 2, 5, negative 5 down there. It doesn't really matter. 0, 0 is just the easiest one. Okay. If you can't pick 0, 0, if a line goes through 0, 0, you might want to pick like 1, 1 or 1, 0 or 0, 1 or something like that. All right, awesome. Here we go, let's plug in 0, 0. I'm just going to plug it into the original, so I got 2 times 0 plus 5 times 0 is greater than or equal to 10. So again, you could plug it into this y equals mx plus b equation here. Doesn't matter. Either one's going to give you the same answer. So now these guys both go away, so now I have 0 is greater than or equal to 10. Is 0 greater than or equal to 10? No. So 0, 0 does not work, so that means I shade everything that is above that. So that's why I'm going to shade up there. Okay, so graphing linear inequalities. Don't forget to dash or solid, and don't forget to toss some shade. Thank you for listening, and make sure you come find me if you have any questions.